So today it's all about using the derivative to find the integral. Okay, using the derivative to find the integral. Integration by recognition is like another way of saying that, apparently. So it's in your success criteria. You get given information about derivative, or you find the derivative, and then you use that information to find the integral. Well, its main use is if you have an integral and it's not part of your general rules. So it's a strange function that you haven't seen before. So what you can do is find the derivative and then use that to just go backwards. This next one is not revision. This is definitely something you haven't seen before. Okay? So we have an equation. It wants us to find the derivative and then use that to find the antiderivative. We use this if it's not in our general rules. So we have this x squared e to the x cubed. It doesn't look like we can do it regular integration wise. It looks too complicated. So we find the derivative of this first. Okay, so we have to use what's it when there's a function within a function. So let y equal e to the u du dx and dy du is what we need to find. And then what do we do with those two? Do you remember doing this? What do we do with these two to find this? I think someone said multiply. Good job. So we find these two and then multiply them together to get the overall derivative of this function. So if your head's hurting, it's because we're getting to the end of derivatives, integrals. Let's say, so du dx. So if u is x cubed, what's du dx? 3x squared. Okay, I know you haven't done a lot of derivatives lately. We bring the power out the front and minus 1 from the power. That's derivatives. Okay, what about if y equals e to the u, what's dy du? Remember my lame poster over there? It says when you do the derivative of e to the x, nothing happens. Yeah, so it's just eu. Okay, you sub them both in. EU, and we can sub in what u is for x. We use that derivative now to find the antiderivative of this. How do we use this derivative we found to find the antiderivative of this function here? We need to rewrite it in integral form and simply rearrange. So we're going to rewrite this. So we want the integral of x squared e to the x cubed. We just found that this integrated becomes this. So if we want to get this, what do we need to do? So we integrated, we differentiated to get this, yeah? So we know the integral of this is that. So there's no 3 at the front of this one, right? So we simply just take the 3 out the front and it becomes so we use the derivative to find the integral. So this is the product rule written simply. So if u is x, the derivative of u is 1. If v is cos x, the derivative of v is negative sine x. So then you put it into this formula. So we found the derivative. Now we need to try and rearrange it to find the integral. So you express this as the integral. What is the integral of that? X cos x, so the original function. So we need to try and rearrange that so we have the antiderivative of x sine x. Oh, I didn't put the dx here. So remember, if you have an integral of all of that, you can split it up. Remember this? Oh, you don't remember this. Because you can integrate each separately because they're separated by a plus or minus. We're trying to find that. So you have to rearrange it so that's by itself. X sine x by itself. So there you go. Multiply everything by -1. So then you're left with sine. So I just split that up into 2 steps so you can see the multiplication. So it's positive here, so then I multiply by -1.